The purpose of today's notes is to continue our lesson on stoichiometry, but now we're going to be using an additional conversion factor, which is going to be using the concentration of a solution. So if you recall, concentration is measured in molarity, and molarity is solved by looking at the moles of solute that you have over the volume of solution. So for example, if you have 6 molar hydrochloric acid, that would mean that you have 6 moles of hydrochloric acid per 1 liter of solution. If you were looking at the next example with sodium hydroxide, 0.05 molar, which is very unconcentrated, would be 0.05 moles per liter. So the lower the amount of moles, the less concentrated it is. So you're using this as a conversion factor, because if we look here, we can convert from liters to moles using our molarity. So we just have to remember that capital M means molarity, and that is going to be moles per liter used as a conversion factor. So if we look at our first example, we have a decomposition problem. So we have glucose here decomposing into carbon dioxide. And when we balance this equation, we're going to be seeing this is a 1:2:2 ratio. So we're being asked to find how many liters of CO2 gas are produced if we have 15 grams. So this is kind of warming us up from what we were talking about in our last lesson. We're not quite at the point of using the molarity. We'll get to that in the next one. So just to warm up, I'm going to go through this problem quickly. We're converting 15.0 grams of sugar, glucose, and we are trying to figure out how many liters of CO2 gas are produced. And again, this is just a warm-up problem. If you are coming from the last set of notes, this should be somewhat of a review. So first thing we have to do is use molar mass to convert from grams of glucose into moles of glucose. So you add up, it's relatively heavy, 6 carbons, 12 hydrogens, and 6 oxygens. From here, grams will cross out. You're going to use your mole ratio to go from moles of C6H12O6 into moles of CO2, your desired quantity. It's going to be a 2:1 ratio. And now our last portion is going to liters of CO2 because it's a gas. So moles of CO2 into liters of CO2. And if you remember, 22.4 liters of any gas is 1 mole at STP. So we're going to assume here we're at STP. It doesn't say otherwise. So 22.4 liters per 1 mole. So now moving on, if we want to use that molarity here. So we're being asked to find how many grams of silver, which is over here, are produced by the reaction of 350 milliliters of 0.300 molar silver nitrate. So if we see that we have 0.300 molar, that tells us, if we remember from the 2 slides ago, molarity is measured by moles per 1 liter. So, this tells us that we have, that we have 0.300 moles per liter. So that's going to be a conversion factor we're going to have to use at some point. Now, what's a little bit tricky about this problem is we're being given a quantity to start with in milliliters. So because we're in milliliters and molarity is measured with liters, we're going to have to do a unit conversion to get milliliters into liters. So let's get it started. Oh, and before we do that, we do have to balance the equation. So we should have those 2's in place there. So starting off with our milliliters of silver nitrate, we want to convert this first. 1 liter is 1,000 milliliters. Once we get that into liters, we can now use our molarity as a conversion factor because that will get us into moles. And if we're in moles, we can go and convert to other things from the balanced chemical equation. So we're going to use that molarity where we want to put liters on the bottom and moles on top. And this is going to be for our silver nitrate. I forgot to write that. So liters will cross out. And now we can go from moles of silver nitrate into moles of our desired product, which is silver. So moles of just the plain silver. This is a 2:2 ratio based on our balanced chemical equation. And we're trying to solve for grams. So that means our last step should be going from moles of silver into grams of silver. So taking a look at the periodic table, finding silver, we see that 1 mole is equivalent to, let me see here, 1.07, is that right? Yes, 107.87. And we'll cross out, making sure the units all cross out, we should get 11.3 grams of silver overall. So give that one a try, see if you get the correct answer there when you go through it, typing it into your calculator. We're going to try a couple other practice problems with this concept. So in this problem, we want to balance everything first. So as we do that, here we go. We're being asked here to find how many milliliters of 4 molar hydrochloric acid are needed to produce 30 milliliters of 1.5 molar manganese chloride. So 2 things that are given to us besides our 30 milliliters that we are starting with are going to be our molarities. So keep in mind that molarity is moles per liter. Okay, so this tells us that for our HCl, it's 4 molar, which means it's 4 moles per 1 liter, and 1.5 molar of the manganese chloride is 1.5 moles per liter. Okay, just keep that in mind. So we're starting with 30 milliliters of our manganese chloride. And our first step, we can't use milliliters. Remember, your molarity is in liters. So if you have milliliters, you need to get that into liters. So use your basic conversion, milliliters to liters. It's going to be 1,000 and 1 on the top. That will cross out. And now that we are in liters, we can use our molarity. So it tells us that we're working with 1.5 molar. So that tells us we have 1.5 moles of the manganese chloride per 1 liter. Liters will cross out, and now that I'm in moles of manganese chloride, I can use my balanced chemical equation and a mole ratio because I want to go from moles of the manganese chloride into moles of HCl. That's my desired quantity. So this is going to be a 4:1 ratio. Moles will cross out, and now I'm in moles of HCl. Now it's asking me how many milliliters. So I know from the molarity problem how many moles are in a liter, so this is going to require a couple more steps. So moles is going to go on the bottom for a hydrochloric acid, liters is going to go on top. So we're just taking this conversion factor and we're flipping it upside down, which we can do, to make sure that we can cross our units out and get into our volume units. So if we look at the molarity, this is going to be 4.00 moles per 1 liter. Moles will cross out. I'm being asked to find milliliters, so my very last step is going to be going from liters to milliliters, which is 1,000 to 1. So finally, type all this in your calculator. It's a relatively long problem. You're going to get 45 milliliters of hydrochloric acid. And our very last problem, again, we're going to have to start off with balancing this. So if you go through and balance it, you should find the only coefficient you need is a 2 in front of that hydrochloric acid. So we're being asked to find how many milliliters of 12 molar hydrochloric acid are produced if we are reacting 500 milliliters of COCl2 gas with excess water. So that means we have plenty of water, we don't need to worry about it. But we do want to figure out how many mLs of our hydrochloric acid. Keep in mind, I put that dot there just to show that this is exactly 3 sig figs. So if I were to put a 0.0 after that, that would imply further significant figures. So I've been trying to keep up with correct significant figures throughout this screencast if you've noticed. If you haven't, that's fine. But that's why that period there, it's not a typo. So we are told we have 12 molar hydrochloric acid. Knowing that molarity is moles per liters, that tells us it's 12 moles per 1 liter. And we are starting with 500 milliliters of COCl2. So I can't use any quantities with milliliters here. I have to convert this into liters, so that should always be your first step, going from milliliters to liters, which is 1,000 to 1. Milliliters is going to cross out. I'm going to have liters. And now that I have liters, it tells us it's a STP, so we can go from liters back into moles. Remember, anytime you're doing stoichiometry, You have to be working in moles to go from one unit to another. You can't use grams or liters or anything like that. Got to be in moles. So Cl2, it's going to be 1 to 22.4. Liters are going to cross out. Now we're in moles of CoCl2. We're attempting to get to hydrochloric acid, so you want to go from moles of CoCl2 into moles of hydrochloric acid. Based on our mole ratio, it's going to be a 2 to 1. Moles are cross out. So we're left with moles of hydrochloric acid. I need to get to milliliters of hydrochloric acid. So now I'm going to utilize my molarity, 12 molar, because I know the moles per liters. So 1 liter of hydrochloric acid contains 12 moles if it's 12 molar. The moles of hydrochloric acid cross out, and if I stopped here, I'd be with liters of hydrochloric acid, but I'm being asked to find milliliters, so my very last step is just going to be going from liters to milliliters, which is 1,000 to 1. So overall, we should get 3.72 milliliters of hydrochloric acid. So hopefully this makes sense. Molarity is just an extra conversion factor that you have to use in stoichiometry. It's still the same steps that we've been using the whole time.